In the background you will see our full ring autonomous, which delivers both wobble goals, shoots 6 rings into the high goal, and parks. There are many different controls which go into making this possible. One of the first controls we use is motion profiling. Motion profiling generates more controlled movements by creating a range of motion. So, essentially creating velocity and acceleration functions based on the position the robot needs to go to. This is a large help in keeping our auto consistent and smooth. From watching our video, you may be wondering how we follow our paths. We do this by generating trajectories and following them. These trajectories are like paths the robot follows, with it also being constrained by the motion profile. Most of our trajectories are splines, as seen here. Put simply, a spline is a piecewise function which is created through drawing lines to points, also known as interpolation. This helps us avoid many common problems such as path continuity exceptions and oscillations at the edges of an interval. Shown on top of our autonomous right now is a video of a feed-forward tuner. We use this tuner as an easy way to obtain more exact feed-forward coefficients. Feed-forward allows our robot to move at exact speeds with very little change, by controlling how fast these variables are changing. Being shown now is our through-wheel odometry. This uses data from sensors known as through-bore encoders to define our robot's position or pose. To calculate our robot's change in position, we use a series of differential equations. The primary equation used is shown on the screen right now. Here's our vision in action. What we are using is a contour ring pipeline which filters out a lot of the area around the rings, finds and draws contours around the rings, then creates a ratio comparing the width to the height in order to determine the height of the ring stack. We go into detail on this as well as other autonomous enhancements in our portfolio. In order to have a consistently fast shooter, we use PID, which finds a correct output using the difference between our target and our measured values as a control variable. The value given is used as an input for reaching the target velocity or position, in the case of our wobble goal. Another enhancement is our use of command-based programming. It allows us to run commands or functions in parallel or series. Shown here, our driver is doing multiple motions such as lifting and placing the wobble goal while driving and intaking. Here's a video of a driver enhancement known as squared inputs. Essentially what we're doing is we're just squaring the inputs so the driver has better control over the robot. They can drive at slower and faster speeds. Finally, we have our auto power shots, which just has the driver press a button to shoot down all 3 power shots.